Hello. We're continuing with Lennart Koopmann with log analysis with Graylog2. Have fun.
So this should be okay. That sounds good. So I did this talk with Jordan already this morning. We were talking about log management in general, and Jordan did his talk about Logstash right after that, and now it's my turn, and I'm going to talk about Graylog2. And first of all, I'd like to thank the NetWays people, because so far it was a really great conference, and I really enjoyed being here, and it was really well organized. So thank you for that. So just a few things about me. So my plan for today is that I have just a few handful of slides, and then I'm going to go over to a demo of the whole thing, because I tried to, or in the past, I tried to explain the whole thing with slides, and I failed horribly because it's hard to explain all the stuff that it's doing. So my plan for today is to do the longest part will be a demo, and then we'll have some time for Q&A afterwards, because the experience shows that there are usually a lot of questions. About me, I'm 25 years old. I'm living in Hamburg, in Germany. This is my Twitter handle, and I'm also the co-founder of Torch, and that's the company behind Graylog2. But that's all that I'm going to say about Torch for today. I think maybe there's one sentence about it later. So everything today is about Graylog2, which is open source. You can just download it, all on GitHub, all documented, ready to go and ready to try it out. And I always include a bit of the Graylog2 history, because I think that's important to know. Who of you has heard of Graylog2 already? Can you raise your... Yes! that's everybody. Who was using Graylog2 or is using Graylog2 right now? That is also good. And who of those who just raised their hand is already running the new version, the 0.20 series? That's also good. Because I think it's important to know that we have this new version that we launched in February, and I started this whole thing in 2010, that was really just me developing the whole thing in my free time. So after work, I wanted to learn a new language. That was 2010, and I decided that I wanted to learn Java. So I learned Java with this thing. This is also a reason why I rewrote it 3 times, I think, because I started writing Java like I was programming PHP before, that had to go through a few rewrites, I think. Then I founded Torch, is a company behind that, and now we're working with a team of 6 people right now in Hamburg, full-time on that, and we have already hired more people, so this is a bit outdated, and we'll be around 10 at the end of summer, I think. Everything you need to know, I think, after this presentation, you'll find on graylog2.org, I hope. There's all the information, download packages, documentation, Gulf libraries, everything you should be able to find on that website. We started to rewrite the whole thing, I could say, in 2012 already. And that was because the system has grown from, I don't know, are the Jimdo people here in the room? Maybe somewhere. That was where I started the whole thing, and it was the requirements that we had was that the system must be able to handle a total number of messages of around 70,000. So it had to manage 70,000 messages. Today we got customers that are sending 100,000 messages per second. So the whole architecture had to grow a bit with that, and this is why the history is. I would say we've gone through a few rewrites and a few fundamental changes of the architecture. So we started with MongoDB as a message storage that is now Elasticsearch. The web interface was written in Ruby on Rails before, and we replaced that for the new version that is out now for a Java version using the Play framework. Just because if you're not a Ruby person, I can understand that it's really hard to deploy that stuff. And I don't know if somebody who's been working with the old version before and is not a Ruby person maybe went through getting all the dependencies together on an old Red Hat Linux or something. So it's also very easy to install now, I hope. And the web interface is also focusing on more analytics. And another interesting aspect, I think, is that the whole communication is now REST-based. So I'm going to show more. I'm going to show the basic architecture of the system on one of the next slides. But the communication that the web interface is doing, and that is what I'm going to show in the live demonstration. You're going to see the web interface. The communication that the web interface is doing is only REST-based. So the only dependency of the web interface is a Graylog2 server node somewhere, which is spawning REST APIs, which means that if you have reporting scripts or monitoring systems, anything that you want to run against your message base, you can do that, and you can manage the whole system via REST, because everything the web interface is doing is documented REST calls. Oh, most of them are documented, I hope. So it's also really easy to extend, I think. And this is like if I always had the problem when somebody asks, like when my mother asks me, what are you actually doing? It's like really hard to explain. And if I want to explain that to technical people, I came to the conclusion that this is kind of what we're doing. So it's free and open source, and we are a product, or we're building a product that allows you to analyze any machine-generated data in your own data center. And it's running on the JVM in your own environment, so it's not software as a service or something. And most importantly, you're not limited by any licenses. So if you've been working with some commercial log management tools out there, a lot of them limit you by the license. So they say you buy a license that gives you 50 gigabytes of log data, and if you exceed that, you're logged out, unfortunately, and you have to get a new license, a bigger license. And we've seen that in some big companies that led to projects where a manager was going around and telling the developers to log less. He was like, we have this 50 gigabyte license or 100 gigabytes, that's so expensive already, you can't log all your stack traces, cut that off somewhere. And that is, I think, like the complete opposite of what you want to do in the year 2014. You want to log everything, and you only want to be limited by your own hardware resources, I think. Because in the moment when you're logging something, you don't know yet what you'll be needing later. So trying to reduce the amount of logs just because your manager bought this too small license, that is happening out there right now, and that is very important for us. You're not limited by any licenses because the license is the GPL. You can basically do what you want. This is the basic architecture. And this is actually a really basic architecture, but also something that I think you could put into production like this. You got the message sources, so that can be, for example, your Apache daemon somewhere, writing assess logs. Maybe you have a log stash running there that is parsing the logs and is forwarding that to Graylog2. That can be your Java application with log4j sending messages directly to Graylog2. That is where the messages are coming in, and this is the little line here on top of the Graylog2 service. That's like 4 little lines because you can spawn as many inputs as you want. I'm going to show that in the demonstration. And the Graylog2 servers, you can think of them like workers. You send a message in, they are processing the message, and then they're writing them to Elasticsearch. We have another dependency, which is MongoDB. That is, for now, still a dependency, which will be gone soonish, I would say. So the the underlying architecture there is already abstracted, so we will be able to allow you to use MySQL, Postgres, CouchDB, I don't know what, because we are really not doing anything special with MongoDB anymore. We are really just writing meter information like users, stream configuration, web interface configuration, stuff like that. Parts of that is in MongoDB, and that's something you could easily store in MySQL, for example. So you still need a MongoDB, but there won't be much load on it. You don't really have to replicate it. Just put that somewhere. That's fine. And then there's the Graylog2 web interface, and that's what you're going to see in the demonstration. And that is communicating with the REST APIs in the Graylog2 server. And you see here that you can hook whatever you want into the REST APIs. The REST APIs are completely authenticated. So we're having a user model, an authentication model, permission model, stuff like that. And that starts at the Graylog2 servers already. So even if you are in the same network, you still have the permissions to request messages or to create streams, to spawn inputs, stuff like that, even with curl calls. So it's not only authenticated in the web interface, it's authenticated at the REST APIs already. So if you don't want to use the web interface and just provide the Graylog2 service as a way for your employees to assess data, that's no problem. That's something that you can do. I'm also always quickly going through some architecture considerations because it's really not hard, and it's interesting to know if you think this is something you want to look at, and maybe you do a proof of concept. That's already something which is good to know before you start. We have Graylog2 Radio, which you can use for high availability and a high-level buffering. If I go back to the slide before. That is something that you put in front of the Graylog2 service, and that is spawning something like a message queue in between, which means that you can shut down any part of the system behind it without losing any messages because it's writing to AMQP or to Kafka. That is all tightly integrated into the Graylog2 infrastructure, but I'm also going to show that in the demonstration. So. Also look at Graylog2 Radio. That's a separate package, separate documentation, but that's good to know, I think. And then you can just put load balancers in front and scale out horizontally as you want. So the whole system is built to be scaled horizontally because we've seen that people usually start with a proof of concept, and in a lot of cases, this proof of concept grows into the actual production setup later. And so Elasticsearch is perfect for that already, but we have taken care that our infrastructure is also able to grow with your needs or to shrink with your needs, maybe. When you're thinking about scaling the whole thing, this is just really rough guidelines. It always depends on what kind of messages you're sending in, but this is something that you can use to get an idea like how to scale. For the Graylog2 servers and the radios, you should definitely focus on CPU. So the Graylog2 infrastructure is not very memory hungry anymore. I would say that was different in the past. We see that you should really put a focus on CPU there, not so much on the memory. And the memory usually is not growing much. So it's always staying on kind of the same level, and then you figure that out at the proof of concept already. Then that's usually no problem. For Elasticsearch, however, you should definitely focus on enough memory and also on I/O. We see that the quality of a Graylog2 setup is always really tightly coupled to the I/O speed of Elasticsearch. If you're sending in a lot of messages, some people are sending in 100 messages per second or something. That's nothing you have to worry about. That's nothing where you have to worry about I/O. But if you are, we have one customer who's sending in his proof of concept already 100,000 messages per second. That guy, of course, needs some really fast I/O. For MongoDB, you can, if you want, you can set up a simple replication set, but there's not much load. That's really just, there are a few queries going against that. You can put that on like a really small VM, maybe even together with the Graylog2 server nodes. And that's like I said, that's going to go away in the future versions. And the Graylog2 web interface, also something where people usually think, that's something that maybe we need to scale. Usually you don't have to, because Graylog2 is one of those applications where there won't be like hundreds or thousands of people navigating on your Graylog2 web interface for the same time. And also, basically everything it's doing is it's accepting the requests from your browser and translating that to REST requests against the Graylog2 server, and then it's just waiting for the answer. That's all it's doing. Just really small box, small VM maybe, and don't have to care much about the web interface. That's really not a bottleneck at all usually. If you want to learn more about that, this is I just gave the slides to somebody from NetWays, so that will be published afterwards, I think. That's on our support pages. There's a list of suggested setups. So if you want to look into that in more detail, that's documented there. So this is something with a radio setup. You see, you can go really complex there if you want, but that's for a fairly big setup. The smallest setup, by the way, is one MongoDB server. or one MongoDB node that can all be running on the same machine, of course. One Elasticsearch node, a Graylog2 server, and a Graylog2 web interface. That's all. Just all that together on one node, and you're good to go, and you can start. And because everything except MongoDB is running in the JVM, it's also, I think, really easy to set up, because getting a JVM on your system, OpenJDK, it's not a problem, I think. However, you need Java 7. The web interface won't boot with Java 6, but don't think that should be a problem. Another concept that we think is important, that's something that we learned from enterprise users, I think, is that it's really important that you're never losing any messages. And we were struggling a bit in previous versions with the internal set of buffers, and so we are using the disruptor library from Elmex, which is blazingly fast. So we have buffers and caches internally. There are messages floating around in the heap somewhere for a few microseconds or milliseconds, and we are really taking care that you're never losing a message that was accepted by a socket from Graylog2. So if you're sending with UDP, that's not our problem. If that gets lost somewhere, we don't care. But if you're sending with TCP or something and the message was received, then you can be pretty sure that the message is being written to Elasticsearch. And if it's not being written to Elasticsearch, I think, wait a second. There you see. That's something from the web interface. It's also reporting if it failed to index any messages. Because if it fails to index a message, you at least want to know about that. And it's also writing that to a dead letter queue. So you can later reprocess the message and try. Maybe it was just a temporary Elasticsearch timeout or something. The message is never lost. The original message in its original format is still stored in MongoDB, and you can just replay that later if you want. However, what you see here is something that's pretty new. I think this is in the currently released version is 0.21. And this is something that will be coming in 0.22. We have a snapshot on that on GitHub already on the packages, if you want to try that out. It's running stable, it's just not feature complete because there are 2 features missing. But that should be released within a few days, I think. And the whole demonstration, by the way, is all this. That's my development version. That's what will be released with version 0.22 later. What you see here is that there's a graceful shutdown happening. So the old version was just JVM exit. Any message that was in the buffers somewhere in the heap was lost. And that's something that we just started doing. It's something you can see here is that I think I tried to kill the Graylog2 server process, and then you see that it's trying to get itself out of possible load balancers that you might have. It's starting a graceful shutdown. It's closing all the inputs so no new messages are accepted. And then it's actually waiting until all messages in caches and buffers are processed and acknowledged by Elasticsearch. And then you get the goodbye message and the server is shutting down. So even when you kill the whole thing, if you don't kill 9 it, you're still not losing any messages. Okay, we got that. We also have Gelf. Gelf is the so-called Graylog2 extended log format. That's a name I made up. That sounds very important. In the end, it's really just a JSON string that allows you to send structured messages when sending already. There's more information about that on graylog2.org/gelf. There are more interesting stuff about that. For example, that I kind of rebuilt the TCP sequencing on top of UDP packages, which is working surprisingly good. And that is if you don't want to use TCP. I think I was talking about that in the talk this morning. There are reasons not to use TCP for logging. For example, if you're sending from within your applications, you don't want to care about timeouts, slow connections, connection aborts, all that kinds of stuff. So maybe you want to use UDP, but then you have this huge Java stack trace or some XML payload or something that you want to log with it, and then you're quickly approaching the maximum size of a UDP package in most networks. So I built something on top there that allows you to send a message in multiple UDP packages and that message is later reassembled by the Graylog2 server. So you can split up a huge message over small UDP chunks, so you can send huge payloads, but still without TCP and stale connections and stuff like that. And we already have over 30 libraries there from the community. So if you want to use Gelf to forward any message that you're writing with Log4j, for example, there's Log4j appender. There's for Erlang, C, Go, Node.js. I don't know for what. There are a lot of libraries that you can just use out of the box. Just point the library to your Graylog2 server and start sending messages over. And Logstash, for example, also has a native Gelf output, so that allows you to read a file, process it with Logstash, and then forward it as Gelf to Graylog2 and get structured data. The streams, I think that's the last slide. This I always try to explain the streams, and I see myself failing in the beginning already. So streams allow you to match messages when they are arriving in the Graylog2 server. So you're sending a message to the Graylog2 server, and you can define rules. I'm also going to show that in the demonstration. Maybe then it makes more sense. But you can create streams like, for example, SSH logins. And you define a rule that identifies a message as a SSH login or as something that shows and as an SSH login. And you can think of that like a saved search, for example. So you click in the web interface just on the link SSH logins, and then you get all the SSH logins. Now you could say, okay, I can also save my search. That's the same. But streams, because they are running in real time, also allow you to do some real-time operations on that. So you can define alerts, for example. You can say, when there are more than 200 SSH logins in the last 3 minutes, then raise an alert, send me an email, do something. But I think that will make more sense when I show that in the demonstration. Yes, that's the last one. Yes, you mean Kibana, not Logstash. You mean the Kibana web interface, right? So what Kibana is doing, Kibana is sitting somewhere here and is going directly against the Elasticsearch cluster. That means your browser is doing AJAX calls against Elasticsearch, which means that your browser, if you don't put some proxies in between or something, needs a direct connection to Elasticsearch. That's something that we don't have. That's important for, like, for example, for banks, for anybody related to military, for example. They can't like put all the data in there because then your ACLs, for example, get kind of useless when you can like query Elasticsearch anyways directly. So what you can do here is that you can separate that in your network if you want. So you can completely hide away Elasticsearch, MongoDB, everything here from the web interface and from the user. Actually, you can only give, if the user is sitting here, you can just give him access only to the web interface, and that's it. And even if the user should get access somewhere into this network, he still needs to authenticate and have the access rights to access any messages in the REST API. Yeah. Because we are doing a bit more, still a bit more than just plain settings, and I think that could work with Elasticsearch. But when we tried it with Elasticsearch, I know a year ago or something, we had some problems with how Elasticsearch works with atomic updates and stuff like that. So Elasticsearch, in the end, is a full-text search engine, and we had some problems to put the data that we needed into Elasticsearch, and we felt like this didn't really feel right. But we know that MongoDB, of course, is a dependency that a lot of people don't want. We can understand that, and this is why we're having an abstraction layer there. And soon you can use. I mean, everybody has some database somewhere that he can use. I hope at least. But maybe we'll even have something like running in the JVM for a quick start. Some database running in the JVM or SQLite or something if you want to. Okay, if you have any questions, by the way, in between, just interrupt me. That's totally fine. And I forgot I wanted to repeat the questions. I will from now on repeat the questions when somebody has a question, sorry. Good, and then let's do a demo. Where do we start? Let's start at the authentication, I think. That's good. So this is, if you have it installed, this is the first thing that you see. And this is already the first difference, I think, to to other open source solutions for this out there is that you're not getting anything without logging in. So I'm logging in with my local account now, and that will be an administrator account, so I can do whatever I want. I'll show you the permission stuff later. By the way, everything that you're seeing here now in the demonstration is all running locally on this MacBook Air here. That has, to be honest, that has an SSD, so it has fast I/O. But still, if you look at response times and everything, that is all, like every single service is running on this MacBook Air here on my on this table. So let me sign in. And this is the first thing that you see. First of all, you get this bubble that always makes me nervous. We had another animation there that made me really nervous, and I had to change that. But I'll show that in the next step. So this is like the first page you get, and that is a bit, let's be honest, that's a bit boring, because that's really just a plain search field. But I'll show the search field later, because I've seen that it makes sense to start with the system area, so you get an idea of how the whole thing is actually working. And this is this nervous red thingy up there with the 2 is showing me there are 2 important notifications. The first is that an input has failed to start. This is, to be honest, 5 days old. But it seems like I tried to start a node, a Graylog2 server node, and that was trying to connect to AMQP, but the connection was refused because my RabbitMQ was not working, not running locally. And then you get like little links, how to solve this stuff. I don't know, where's that going? Oh yeah, that's taking you to the inputs, which I'm going to show in the next step. And then also we identified some classical failure cases that everybody seems to struggle with, and that we got a lot of support requests for. And one of them was that people are running their Elasticsearch nodes with standard settings. Of course, I mean that's what I did when I started with Elasticsearch. But Elasticsearch needs a very high number of allowed open files, because Elasticsearch is keeping all those Lucene underlying segments open, has a lot of open files, and the number of open files grows by time. And that means that everything will be running in the beginning, and then 2 hours later, without anybody doing anything, it's just exploding spectacularly because it hits the open file limit. And that is, Elasticsearch shows that everywhere already, but still, it's like, I can understand people forget that. So the Graylog2 infrastructure is already checking for a lot of those error cases that will cause problems in the future. I never fixed that because that's my local machine, and I never have many messages, or not extreme amounts of messages in there. So I always get this warning. But I could, for example, this here is AMQP input. I'm not really interested. That can be gone. Unfortunately, we have a little CSS bug here. This is because I was doing the front end. This is overlapping a bit. This is because we have a fairly small resolution here, but I don't think that should be a problem. So I can, let me simulate that. Should be like this, but I think we can all live with that. Okay, then we got, so this is the system overview page. You see that there are no active system jobs. We got periodical jobs running in the background, optimizing indices, moving data, stuff like that. That's something that you would be seeing there with a little progress bar and stuff like that. Then we get a little overview about the Elasticsearch cluster. It's all green, it's all good. We got 170 shards. They're all active, 0 initializing, 0 relocating, and 0 unassigned. If you want to learn more about that, we have the web interface is full of those little help buttons. And then you see that this is taking you to support.torch.sh and the Elasticsearch cluster status explained. So we try to give the user help wherever we can with some documentation pages. This is this indexer failure list, which I was showing you already. And then we have a lot of system messages. The reason for this is we always had the problem that we were probably the logging system with the worst logging out there. So it was always a problem to find out what the system was actually doing. And of course, your first idea is, well, we're a log management system. We can just log into ourselves. We tried doing that, and we spent a day creating horrible fork bombs. Because what you're doing is, you are writing into Elasticsearch, and then you are getting an error maybe because somebody shut down the Elasticsearch node. That causes an error message, which will be tried to be written to Elasticsearch, which causes an error message, which causes, and then your fan goes up, and then you can shut down the notebook, basically. And we never ever solved this problem so far. And I was talking to Jordan this morning at the breakfast, and it seems like they are having the same problem. So it's not us being dumb, it seems, at least. And that's why we're having the system messages. That's coming out of MongoDB. So we said, like, okay, then we are having like this little isolated, all exceptions caught, just try to write your stuff somewhere. But that's not the actual logs that the server is writing to stand it out. That's also something else. This is really like nice data to see what is happening. So I was starting an input. I was starting a lot of input, and one of them failed. So predefine nicer messages of what is happening. I'm going to show you the actual logging in just a second. Now I'm clicking on the nodes, and I see that I forgot to start some nodes. Oh, ooh. Where is it? There it is. Don't kill it. So this is the node overview list. And you see that we got one Graylog2 server node running and 0 radio nodes. I just started 2 radio nodes. So if I refresh now, we should see 2 more radio nodes. There we go. The stuff that is moving here all the time, or should be moving, yeah, it's moving. This here, and here, and here, is the heap usage of the Graylog2 nodes that are running. That can be interesting if you're in production and you try to find out if you have assigned enough heap space or not, because you can actually see the garbage. If you that was a garbage collector. No, do it again. No, garbage collector. Garbage collector. So you can actually see how the memory and the garbage collector is behaving in production. Honestly, I just built that because it looked nice. And then everybody loved it and was like, I mean, you look at it and you get an instant feeling of what is actually happening. And then if we are looking into installations that are having problems, then you usually see like everything here happening only like all the time, and you don't even have to look into some GC logs or something. That's all information that's coming out of the REST API. So if you want to hook that into your monitoring system, that's not a problem. You can just do that. And then you see that here, we got one Graylog2 server node, and that is getting 42 messages per second right now, and is taking around 100 megabytes or 132 megabytes of heap space for that. So that's the actual. If you're not familiar with the JVM, that is the actual memory that the process is using on your machine. Then you have some more information. You see the. I can actually have the little buttons here. You see that the current lifecycle state of this thingy is running. That could also be, if we are shutting down the system, then that will be halting until it's actually shut down. This is this graceful shutdown that I showed you. You see that the message processing is enabled, so I can also say like, nah, stop processing messages. Then it's paused. The lifecycle state is paused. And now I could, for example, shut down Elasticsearch completely. Because it's not trying to write any messages. I can just shut it down, do any maintenance work, move shards, do whatever I want. And then you see here that it's starting to buffer messages locally. And now you should actually see that the heap should be growing a bit, because it's writing more and more messages to the heap right now. And that's also one of the reasons why we have this in real time, because you're of course limited to the heap here. So this is not meant to be to stop the processing forever. Because at some point you'll run out of heap space, and then the process will crash. So this is for like, I don't know, a few minutes of maintenance window. But then let's say, no, resume it, and it was already processed. So it had messages in the master cache, all processed already. I'm not sending any messages to the radio nodes here. This is only for demonstration. And the messages that are coming in here right now, that may be interesting for the searches that I'm going to show you in the next step, they're all generated by a random message generator. So when we quit our day jobs and started working at Torch full time, we suddenly realized that we have no test data to work against anymore. So we were working in our day jobs and had all this data, and it was perfect. We could try everything out. When suddenly we had no data anymore, so the first thing we had to do was writing a random message generator that's generating messages that look like HTTP requests with a poor attempt to make the timings look like real, but actually it doesn't. But it's generating messages. That's fine for local development. I can also quickly show you the API browser. This is coming out of the server REST API right now. So you see this is going against the server REST API port directly. I have to authenticate first, and then I can do all kinds of stuff. So you get a list of all the REST APIs that are running here, and I can do stuff like give me a list of all notifications. And there you see there's this open file notification, for example, or give me a list of all configured extractors, create new, delete. Oh, I need an input ID for that. This is easy. Total count of messages. There you go. So this, if you want to play around with the REST API, you can just use this REST API browser. Okay, not spending too much time in the system area. This is the part where you're launching new inputs. So you need to spawn a socket or something where you can send messages in. So what you do is you go in here and say, I want to spawn a new syslog input that is listening on UDP. Say launch new input. Say on which node you want to launch it. Give it a title, a port, bind address, receive buffer size, all kinds of stuff. Just say launch, and if I press that now, that would like immediately spawn a new socket, and I could just write messages in, and Graylog2 will accept it. You can write your own plugins here. So if you have some own message format or something, you can just write your own plugins. That's even this whole configuration thing here, for example, with a few more configurations. That's all coming out of the plugin. So that's seamlessly working and seamlessly hooking into the web interface right away. That's Java, yeah. Then we have, I'm going to show the users just really quick. We have an LDAP integration, so you can configure the whole LDAP configuration from within the web interface, test the server connection, and even try to log in from here, because I always fail at trying to connect anything to LDAP, so that was really helpful. And then we have the users here, so you can give different permissions. I think that's pretty standard. So let's do something with the data. The stuff that I'm having here is that's all running on my local machine. So well, let me just show it. You'll see what it looks like this. So my MacBook was running here and here, and then this morning, and then somewhere in the night. So this is, of course, not anything that looks like production traffic. What I just did was I just selected a time frame here and just pressed enter in the search bar, which is the same as just typing in an asterisk, which means search for everything. Okay, so I just searched for everything in the last 8 hours, and I got everything in the last 8 hours. And this is the messages that we are generating. So this looks like somebody requested /posts, took 120 milliseconds, and was replied with an HTTP 200. If I click on that, look at the CSS failing sidebar, then the message is opening here in the sidebar. And you see that this has some structured information already. So an action controller, HTTP method, all kinds of stuff, a user ID. So I can select different time range selectors here. So this one is just relative time frame selector. So search for everything in the last hours, days, weeks, whatever. I can also do an absolute time frame selector, which looks like this. So I can just select it like this here. I can just type it in directly, or I can also just select an area here with my mouse like this. And if you look at the selector now, that's filling it out. Just say search for it. There we go. If you press that together with either Shift or Control, I wrote that once and I forgot which key is which, then we'll execute the search directly, so you don't have to go into the input field and press enter again. And you can also use the keyword selector, which I see that operations people really like to use. Is stuff like, for example, everything since last Wednesday, for example. And then that is translating you that into a proper date. But that's something I don't use that much. And now you want to analyze. Oh well, no. Let's let's show a few searches first. Let's say I want to find every message that contains the keyword get, like a get request. Just type get, press enter. There we go. This is also something new in the new version. We got message result highlighting now. So now it finally looks like this other commercial system out there that also does that in a similar color. So you see that this message was returned because get matched here in this part. I can also do stuff like get and 200. You see, I think you get it. That's a full text search. You can also do stuff like, it doesn't have to be in the message, by the way. I can also do, let's hope that works. Yeah. We had some problems with the fields there in one of the development versions. So you can search in any field here. Yeah.
Would you get 200 milliseconds as well? So you do a full text search, or could you say only 200 for the millisecond part, or for 200 for the response time?
That's what I wanted to show now. So he asked if I can. The short version, I guess, is if I can also select the field directly without doing a full text search, right? Yeah. So let's click on this message again, and maybe there could be a 200 somewhere else, right? Maybe it took 200 milliseconds. I don't want to find that message. I only want to find the messages where the HTTP response code is 200. So I can now either go in here and start typing that, or I just click on the value, and if you look at the search bar again, it's filling that out for me. And I don't know, Shift or Control or something. I just press Enter. There we go. And now it's not highlighting this, because it found this. And now we'll see if this works in the development version. If I do this, nah, that's not working yet. Okay, but it found the message because the HTTP response code is 200. You can also do stuff like, show me everything where the HTTP response code is higher than 200. 500. 500, 504, stuff like that. So you can also select fields directly. The search syntax, I don't know if I have internet here. I seem to have internet. So the search syntax is explained here. So you can do all kinds of stuff. You can do fuzzy searches, wildcard searches, all the range searches, all that stuff, inclusive, exclusive. That's all explained in the documentation. So I'm not going to go through that in detail now. There are two ways to do that. 3 ways to do that. Either key value pairs are extracted automatically, but there's no key value pair in there right now. Or you use extractors, which allow you, I don't think we have time to show that today, but allows you to define regular expressions or substrings or tokenizers or stuff like that to extract information from a message. The message here, however, was sent like this. This was a Gelf message. So it was sent in a structured way already. You can think of that, this information here, like a JSON document that was sent in. So it was sent in a structured way already. That's where the information comes from, and the field names.
Okay. And Gelf runs where on every node?
Gelf, so he asks where Gelf runs. Gelf is just a protocol, so you can send that from anywhere via the network with one of those libraries, for example. Maybe that makes more sense if you look at Graylog2.org/Gelf. It's really just a protocol. It's like putting in a JSON string into a socket, and then this comes out. The search query language is coming from Elasticsearch. So you could also do the same if I, for example, click on this little thingy here. That shows me the Elasticsearch query that was generated. If you want to go against Elasticsearch, I think that was your question, right? Yeah. Okay. Also interesting. Good. So you could just use the whole thing here and go directly against Elasticsearch if you want to. But now maybe you don't. So this is just searching for messages. Maybe you want to analyze the whole result set. So let's say I want to search for everything in the last 2 hours. Everything. So remove that part. There we go. And if you look here, you see that we got a field called tookms. That's response time. That's just, you can use any field name there as you want. I just decided to call it tookms. maybe we want to get some statistical information about the response time of this result set in the last 2 hours. So what I can do is click this little icon here and say statistics. There it is. So we see that the mean response time was 180.81, standard deviation, minimum, maximum, all kinds of stuff. That gets more interesting if you go in here and say, well, actually, I only want to see the mean response time in the last 2 hours of the post controller and its index action. You go here again, say statistics, and then you get only that. Or maybe you want to see, would be interesting which user IDs were assessing the index action of the post controller in the last 2 hours, and how often, and rank them a bit. So you go to user ID, and say quick values, and I hope this is working with the resolution now. Yeah, it's working. So you see that 56.20%, which is 57,689 requests, came from user ID 6469981. You only see 1, 2, 3, 4, 5 user IDs right now because I was a bit lazy and this message generator only knows those 5. But for real data, maybe that would be interesting to see, like get the top posters in your forum, for example, stuff like that. That is also auto updating. You see, if we wait a second, there. And maybe actually I want to generate a chart out of that. So I want to chart the response time of this result set. So I say generate chart. There we go. And then I say, no, actually that should be a line. And then I can pin that, and that means it's in local storage now. So whenever I do another query, that will forever come back until I unpin it. So if I completely reload the page now, that will come back, so we can do some correlation. So let's say, actually I only want to see those where the field took ms is higher than 120 maybe. Do that again, generate chart, then you get another one. Say again, I want that as a line. And now maybe you want to correlate that. So what you can do, we have this little button here. I can just drag that in here and it says drop to merge the charts. And then we get that. I built that with JavaScript and it's working. That's amazing. So we can do stuff like that. And then we still see which query was that, right? You see like the blue one and the red one, and you see the red one is this. I mean, that doesn't make any sense, the query that I did now, but I think you get the point. Then you can go through here and still get all the information. What else? We're running a bit out of time. So we also got dashboards. The dashboards are not as nice as the dashboards of Kibana, I'm afraid, but still, they can look like this. So we can put all kinds of information that we are generating in the web interface on dashboards. Let me quickly show you that. If I search for everything, for example, in the last 5 minutes, we get the result count here. And I can just click those little dashboard icons everywhere and just select a dashboard on which I want to add the information. Dashboards, let's go back here. Because there's one important difference. I think that's a difference to Kibana, which we have seen can become a performance bottleneck, is that if your browser is always doing those requests to update that against Elasticsearch, which Kibana is doing, that can generate some load, especially if you have 5 tabs open and 50 screens somewhere on your wall. We have one advantage there that comes from our architecture, and that is that the Graylog2 servers can cache the information over a pretty long time. So if I unlock this here, I just unlock the widget positions, you see for how long every widget is cached. So we see here this, for example, we don't need that in real time. It's fine to cache that for a minute. So the Graylog2 server will only recalculate this information every 60 seconds. And until then, you only get the cached information. So there's 0 load going against Elasticsearch for this little widget here. We can easily change that at any point in time. We can rename the whole thing. And we can, of course, also move the stuff around a bit, like however we want. That usually works really fine. This is a dashboard without a chart, I think. Do we have one with charts? No. So you can also put those charts that are generated on such a dashboard. Then we also got the sources list. That is something that we left out for the new version in the beginning, and we only added that later in release candidate versions because operations people were coming. So I'm a developer. I never was an operations guy, and this is a list of all sources that are sending messages into Graylog2. And I was like, we don't need that. We have this little quick values thingy that I showed you, which was auto-updating, which was showing you exactly this information if you build it over the source field. But then I quickly realized, or users made me quickly realize on the mailing list that maybe sometimes you're not searching for messages correlated from all hosts, but you want to get one log file on one host. So I can do stuff here. So you go to the sources and you know, what was the host name? Something with DB in it. I don't have something with DB in it now, but I can do like, for example, example.org, and then this will show you only the host that you need. So if you do like something like DB star, you get nothing because I don't have that, but this will show you all database servers. And then again, you just click on it, maybe press shift. I really have to learn that. And then that fills out a query for you again. And then the streams. So that's always hard to explain. Let me see. How do we start with that? Let's do a search again.
Quick question.
Yeah.
If you do not specify any details, any search will go over any log from any file from any host.
Yeah. So if you don't specify anything, it's always searching over any log file on any host, any source, anything that it has in all its buckets. Yeah.
Can this be restricted with the permission model?
Yes. And this is where the streams come in. So let's look at this again. Maybe we want to create a stream that is only showing us messages that were HTTP 500 responses. Yeah? So some errors that were actually shown to the user later. So what we do is, let's do this. Show me all with HTTP response code 500. When we look at that and we see, yeah, we can identify that. We can identify that because the field HTTP response code is 500. So let's go into the streams and say create a new stream. Call that OSDC 500 because you see I did that quite a few times before. Like this. So now we can go in here and say create a new rule. And the rule is the field HTTP response code must match exactly. We can also use regular expressions, greater, smaller, stuff like that. The value 500. Then you see here, this will result in a rule. Field HTTP response code must match exactly 500. You can even look directly at the matcher code if you don't know how something is translated or converted to integers, doubles, floats, whatever. We're linking to our code on GitHub directly. But say save. Now you see here's a rule. HTTP response code must match exactly 500. Let's add another one. I only want those that match the regular expression as something example.org. So only something that is coming from, if that's going to, I'm not going to write a regular expression, no? That's the source must match exactly example.org. Save. So now maybe you want to test that against a message. That was a problem in previous versions. You were always adding all those rules and we were sending in messages and we're hoping that you were actually catching them. So let's go in here. Let's say I'm done for now. Let's save the stream. We have it here, OSDC 500. Now let's search for everything with a 500 again. Now we look at this message and we say, this message should have been routed into the stream, right? Because it's a 500 from example.org. So what we do is test against stream. OSDC 500. Then it's loading the example message here. You see, yep, that would have been a match because this rule matched and this rule matched. And if the background is green, then all rules matched. So let's add another one and say the field user ID must be smaller than 1. That won't match, I guess. Save, red, no match. So this message wouldn't have been routed into the stream OSDC 500. So let's go back into the streams. I activate the stream, saying resume. So it's running now. Streams that actually have some throughput show that to you in real time here. So you see this is, I don't know what that's doing, but it's getting 37 messages per second right now. I can actually show you what it's doing. It's showing me all 200s from example.org. Interesting. And I can click on that, and now I should have gotten, no, no 500s yet. I know why. Because the user ID must be smaller than 1, which is not true, so let's delete that. Go in here, maybe they're the first coming in already. So now you can go in and say, so coming back to your question, if you can put, to your question I think, if you can put user permissions on that, yes. You can now give a user permissions to only see messages from the stream OSDC 500s. If you have, for example, email logs that only specific people should see because it contains raw email addresses, then you can do that. And that reflects back to the REST APIs. So even if you go against the REST APIs, you will never get any message that is not routed into a stream that you're allowed to see. Now, as a last thing, let's go to Manage Alerts and say, I want to get an alert. So trigger an alert when there are more than 100 messages, so more than 100 500s on source example.org in the last minute, and then wait 5 minutes until triggering a new alert, can all kind of stuff here, and say add. Or you can do stuff like, if you're catching, for example, everything from a specific application, you can go in and say, trigger me an alert when the field took milliseconds, has a standard deviation that was higher than 50 in the last 25 minutes, for example. And then you can do that to do a really low-level monitoring of whatever, so of any message that is coming in. So email logs, bounce information, I don't know, all kinds of stuff here. And then you can just add alert receivers down here, and they'll get alerts. And I think, so I would have loved to show you the extractors, but maybe that's something that you should look at yourself if you want to try it out, but we're running out of time a bit, I'm afraid. So if there are any questions left.
Can you write plugins for the notification?
You were able to do that for the old version, and we are re-implementing that for the new version already. So you will be able to do that soonish. Yes, because the alerts, you can request the current state of alerts via the REST API. So if you have Nagios or something, or this awesome iSinger, I don't know how to pronounce it, tool, you can use that against the REST APIs and just request the number of messages or the number of alerts. Are we in a time hurry, really?
We should stop.
Okay, so if you have any more questions, I'm around here now, and I think later at the party, and then we can just have a chat. And I have a lot of stickers with the new Graylog2 logo, which just came fresh from UPS. So if you want to be one of the first to get them, just drop by. Thank you.